All right, so we're talking about regression, and we're going to talk about lines of best fit. So, a scatter plot is a graph of dots as a collection of ordered pairs. The graph looks like a bunch of dots, but some of the graphs are a shape from the survival functions. The graphing calculator is going to give you the correlation coefficient, which is r squared. And this number will tell you how closely the equation is modeling the data. The closer the correlation coefficient is to 1 or -1, the more closely this equation models the data. When choosing regression, it's best to pick the correlation coefficient closest to 1. So 0.99999 is what you want, with some numbers followed after it. So we're going to do some in our calculators, which is what we're going to do in class when y'all come back this week. So calculator steps for regression. These are your steps. And basic steps are really just this: stat edit, stat calc, number, whatever number we're doing, alpha trace. And the number you're looking for is number 4, number 5, number 6, or number 0. So linear, quadratic, cubic, or exponential. And if we're doing scatter plots, we're just going to do y equals and turn the plot on by arrowing up, plot 1 and enter, and then hit and zoom 9. We do alpha trace in the store reg EQ. These are the equations of the lines of best fit. We also use these for Desmos. So y equals ax plus b for a linear equation, ax squared plus bx plus c for a quadratic, ax cubed plus bx squared plus cx plus d for a cubic, and abx for an exponential. And when they give you the equation in your calculator, you'll have to plug in a, b, c, and d. And if we have to estimate, we're going to do y1 of whatever number they've given you, and we're going to find y1 based on this alpha trace. In our Desmos, which is what most of you will have at home, you'll do plus the table in the top left-hand corner. Then you'll write the equation of best fit in the second line, which you'll use from these up here. And then instead of equals, you use this little funky tilde, which is found in ABC. And instead of y, you'll use y1. And everywhere x is over here, you're going to use x1. And then Desmos will give you a, b, c, and d, and it will give you the correlation coefficient. So let's look at what this looks like in your calculators. So let's look at example number 1. And we're going to go over here. Let's start with our calculator first. And so we're going to put this into our calculator, and these are our x's and these are our y's. And so we would do stat and edit, and we would put these in 6, 7, 10, 19, 20, 27, and 36. And we would put these over here in y2, L2, so 276, 260, 220, 388, 430, 550, and 633. Oops. And 633. Then you would do stat calc, and it said to estimate the number of fast food, show a scatter plot. So we would go to y equals, and we would arrow up, hit enter on plot 1, and arrow down. And looking at the data would tell us what kind of equation this is. Well, this sort of appears to be linear. And so we would do stat calc number 4. And right here, we would put alpha trace in the store reg EQ. So alpha trace. And you see there's y1. So we would hit enter and calculate. Well, you'll notice there's no r squared coming up. So if that happens, you would do mode on your calculator and you would go down to right here where it says stat diagnostics. And for most of you, that's on the second screen. And you would turn your stat diagnostics on. Come on, arrow down. And you would turn that on. And then we would quit out of there. And I'm going to hit enter again, so it'll bring it back up. And you'll see here that our r squared is 0.943. So not a great line, but not a bad line. So our equation is y equals a, which is 13 point, we're going to do 2 digits, 607, so 61, and then x plus 150.869 or 87. That would be the equation of our line. Now, if we were to do this in Desmos, we would say plus the table, and we would do, pull up the table, 6, 7, 10, 19, 20, 27, and 36, 276, 260, 220, 388, 430, 550, and 633. Now, you can't see it because we're on a 10 to 10 window, but if we zoom to 200 and something, you will see that your calculator is actually graphing these points. See if I can get them all on the screen here. So I can see 4, 5, there they all are. So it's hard to get them all on the screen, but that's the thing about Desmos. It's hard to get is all of them on the screen, but you can, and harder to see the shape of them, but there they are, all are there. So again, we think that it's linear. So we would do y1, let's see, y1, and tilde is right here. And we say ax1 plus b. And you'll see that it gave us over here 13.61, which is what we got, and 150.87, which is what we got, and our r squared at 0.9438, which is what we got in our calculator over here. So the same things we got in Desmos, we got in our calculators over here. So some things that are better in our calculator, some things are better in Desmos, but those of you going to college, you're not going to probably be allowed to use Desmos, even though some things are easier in Desmos, some things are easier in your calculator. So you need to be able to do them both ways. So that's why I wanted to be able to show it to you both ways. So let's look at example number 2, because example number 2 does something a little different. It says in the problem, it says use a graphing calculator to find the equation of the line of best fit. So they tell you it's a line for the data at the right. And they say let 1990 be x equals 0. So if 1990 is 0, that means that 1993 is 3. So what you do is this is the 0 year. And so you would subtract this from all of these years. So you would subtract 1990 from all of these years. So when you put it in your calculator will do that work for you. So that's one thing that's nice about the calculator. So let's, I'm gonna put it up on the screen here. So whenever you're redoing data here, so stat edit, first clear your data. So arrow up, hit clear, not delete, because if you delete, you'll delete the list. Arrow down and arrow over, and then arrow up, hit clear and arrow down. And so this is 3. We could type 1993 and then 1993 and subtract the 0 year if we wanted to, and your calculator will do the math for us, or you could do the math in your head, either way. So 6, 7, 8, 9, and 10. Uh-oh, I missed one. So this is 6, and I want to enter one here. So I could insert one right here and get 7 instead of having to type them all over. And so I get 340, 369, 402, 430, 457, 489, 527, and 574. Stat calc. Well, let's look at it first. So we assume 9. We've already put the data in. We've already turned our scatter box. That definitely looks linear. So now we stat calc that. Number 4, we're going to store the regression equation in alpha trace. So we get the line y equals 32.333, which is 32 1/3, plus 238.333, and our r squared is 99.29. Now, neither one of these has asked us to, this one did ask us to estimate, and we didn't. So we should have estimated for 14 grams of fat. And what we would have done is we would have put that in here. And we can still do that on this other screen over here. So let's do that with Desmos, since we still have it in here. Normally what we would have done is we would have said alpha trace, we would have said y1 of 14. Now this is the wrong equation, obviously, because this is part 2, but we would have put that in for that one up there. It won't work because it's the wrong one, but we can still do it because we have Desmos on the screen. So over here for Desmos, we would say, we could say, well, basically what you would do is you would say, you take the numbers that are there. You could say 13.61 times 14 plus 150.87. And you'll see on the screen, that's about 341 calories for that one. This one didn't ask us to predict, so that would be all we would do for that one. This one has a prediction and estimate, so we would do this. And it also tells us that the line is quadratic. So let's go do this one. We'll do this one in Desmos here. So we'll add a table. The table is 2, 3, 4. We don't want this one. So 3, 13, 29. So there's our, it's hard to tell that it's quadratic by it's only 3 shapes. So we'll do y1. Remember, it's ax1, and we need to square that, plus bx1 plus c. And it tells us that the equation is y equals 3x squared minus, because it's a negative 5, so minus 5x plus 1. And you'll notice that r squared is 1. That means that makes a perfect parabola. These fit in a parabola just right. And we're going to plug in 10 here. So we would say 3 times 5 squared. Remember, we're using function notation. So everywhere x is becomes a parentheses, plus 5. Minus 5. And we're plugging in 10. I'm sorry, I plugged in the wrong number over there. And then plus 1. And you see that the answer is equal to 251. Okay? And you would continue to do this for this one, which it says, the table shows the height of the water as it drains from the container. Model the data as a quadratic function. So we know this is quadratic. Graph the data and use the model so we're estimating for 35. So we'll put these in over here. I'm going to leave that up there, plus a table. So 0, 10, 20, 30, 40, 50, 60, 120, 120, 100, 83, 66, 50, 37, and 28. There they go. Okay, let's see what our graph looks like. Can we tell? Oh, look at how pretty that is. Nice little quadratic there going on. So it looks like it didn't like it up there. We got to put it in down here. Y1 so AX1 squared plus BX1 plus C. So our equation is y equals 3 A's 1, so y equals, oh, that should be a C. Let's try that again. So y equals x squared plus x plus 1. That doesn't look like the right equation. Let's try that over here. Something's wrong with that. Because I've done this problem before. So stat, maybe it is right. Edit. Let's clear it and see. I'm punching buttons and nothing is happening. Okay, let's try that again. This is what happens when you have online calculators. Da-na-na-na. Let's see if we get the same equation. Stat calc number 5. So quadratic equation, so you know what one looks like over here. Alpha trace, alpha, oh wait, go back up. Alpha trace. I didn't think that equation looked right. Something is wrong. Oh, because those are twos. That's why. See the twos up there, y'all? Helps if you use the right letters. The right numbers. Gotta pay attention to the numbers that they use. Ta-da! Wondered why that didn't work out. Hello. So y equals c. Now you know, gotta pay attention to all the parts. X squared minus 2.104x plus 120.33. All right, moving on. It says the table shows the average in exponential regression. So let's use an exponential regression. So I guess if you do multiple regressions at one time, it's going to use, oh, that one came up x1. Who knows why the other one came up x2? There's no telling. So 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And of course, it wasn't typing. 290, 320, 400, 495, and we still didn't predict over here for 35 because we were stuck on the other. So we do alpha trace y1 of 35. And you get for 35 equals 57.9375 millimeters. This video is all over the place, y'all. Woo. Let's go back over here. 495, 600. Now, remember, exponential equations are y1 tilde. Those are x1s, so that works. So a times b x this way. Remember, it's an exponential, x1. And so our equation is y equals 264.04 times 1.22 to the x. It says, using our written equation, estimate the salary of a baseball player in the year 2005. Now, it says these are since 1984. So this would have been 1984, and this would have been 1985, and this would have been 1986. So what year would 2005 be? So we would say 2005. Remember, minus the 0 year, 1984. So 1, 2, 21. So we want to plug in 21 to this equation. So we would say 264.04 times 1.22 raised to the 21. And that answer would be 17,188. And that's the thousands of dollars. So this is really $290,000. So let's put $1,000 on here. So that's really $17 million in 2005. Okay. So this is what you would do for regression in Desmos or in your TI-84 graphing calculator.